If you've ever worked with Apache Spark, you have absolutely faced one of its most fundamental questions. Today, we are going to settle it for good. RDD, DataFrame, or Dataset? Yeah, which one should you use? Picking the right data structure, well, it's totally critical for performance, for readability, and honestly, just for getting your job done without pulling your hair out. It's a super common point of confusion, but you know what? It really doesn't have to be. That feeling of just staring at three different options, wondering which one is the right one, that's exactly what we're going to clear up right now. We're going to break down the whole evolution of Spark's APIs so you can choose with confidence every single time. So, to really get where we are now, we have to start at the very beginning with Spark's foundational data structure, the RDD. The Resilient Distributed Dataset, or RDD for short, is kind of the granddaddy of them all. It's a low-level API, and what it represents is basically an unchangeable collection of objects that are partitioned and spread out across all the different computers in your cluster. Just think of it as the original building block of Spark. So why on earth would you still reach for an RDD today? Well, there are a few good reasons. If you're dealing with totally unstructured data, I'm talking raw text logs, media files, that kind of thing, RDDs are your go-to. They're also essential when you need that really precise low-level control over every single little transformation. And, of course, if you're working with older Spark code. The real trade-off with RDDs is this. You get ultimate power and flexibility, but you are responsible for everything. You have to tell Spark exactly how to perform each and every step of your calculation. It's kind of like building furniture from scratch with just a pile of wood and some nails. It's incredibly powerful, sure, but it's completely manual. And that manual approach, well, it created a new problem. For the huge majority of data tasks that deal with structured or semi-structured data, like tables from a database, wasn't there a simpler and maybe more importantly, a faster way? This very question led to Spark's next big evolution. And that upgrade was the DataFrame. And let me tell you, this completely changed the game for most Spark developers. This slide right here, it perfectly captures the huge shift in thinking. With RDDs, you're writing code that specifies how to do something. With DataFrames, you just declare what you want the final result to be. You just say, hey, group by this column and give me the average, and you let Spark figure out the absolute best way to get it done. So how does Spark figure it out? Well, the secret sauce is this really sophisticated query optimizer called Catalyst. When you give Spark that declarative code, Catalyst analyzes it, it rewrites it, and it generates the most efficient possible execution plan to run on your cluster. This is where all those massive performance gains come from. It's magic. So the choice becomes pretty clear, right? If you've got structured data, if performance is your top priority, or if you just love using SQL-like operations, the DataFrame is your tool. And for all you Python users out there, it's pretty much the default and most powerful API you've got. This comparison really makes a difference pop. The DataFrame is a high-level API. It forces a schema on your data, which is a good thing. It uses that amazing Catalyst optimizer, and because of all that, it's way, way faster than an RDD for most things you do with structured data. Let's go back to our analogy. If RDDs are like raw wood and nails, then DataFrames are like a high-quality, prefabricated furniture kit. You just tell it the final shape you want, and the whole kit is engineered to be put together in the fastest, most efficient way possible. But wait, the story doesn't end there. The Spark team wanted to combine the very best of both worlds, the safety of RDDs with the raw performance of DataFrames. And this led to the Dataset. The Dataset API is, well, it's a beautiful combination. It gives you all that high-level declarative power and the Catalyst optimization of a DataFrame, but it adds a super crucial feature from RDDs, type safety. And what that means is the compiler can actually check your code for errors before you even run it. Okay, but here's the single most important thing you need to know about the Dataset API. Its true power, that compile-time type safety, is only available in statically typed languages like Scala and Java. In Python, a DataFrame is technically just a dataset row, which means you get the performance, but you don't get those awesome compile-time checks for your data-specific structure. That's a huge deal. So to finish our analogy, a dataset is like that same prefabricated kit, but this time it comes with a smart instruction manual that actually buzzes if you try to use the wrong screw in the wrong hole. It catches your mistakes early, at compile time, long before your job fails miserably in production. Okay, we've walked through the whole evolution. Now let's put it all together in one final cheat sheet to make the choice crystal clear. And here it is, the whole shebang. RDDs for that low-level control, DataFrames for high-level, optimized operations in any language, but especially Python, and datasets for when you want everything a DataFrame offers plus that compile time type safety in Scala or Java. And you might wonder, why are datasets the fastest? Well, it's because their special encoders know the exact shape of your data, allowing for hyper-efficient storage and processing that can even beat the more general optimizations of Catalyst. This quote sums it all up perfectly. Seriously, think of this as your go-to interview answer. RDD is all about low-level control. DataFrame is the optimized SQL-friendly standard, and Dataset adds that amazing type safety and the ultimate performance boost on top, but only for Scala and Java.
So, there you have it. You've got the framework now. You understand the trade-offs between control, performance, and safety. The real question is, now that you know how to pick the right tool for the job, what incredible data challenges are you going to solve with Spark?